Hey team, it's Mr. Z, and today we're going to show you how to use long division to factor. So essentially what it wants us to do is use long division to determine if the given factor is a factor. Okay, so it wants you to prove that it's actually a factor. So in order to demonstrate this concept, instead of talking about polynomials, I want to talk about just regular old numbers. If I take 9 and I divide it by 3, 3 goes into 9 3 times. 3 times 3 is 9. There is no remainder. Since the remainder is 0, three is a factor. If I were to do the same thing, but go with 2 instead, 2 divided by 9, 2 goes into 9 4 times, and it's 1. Notice here, the remainder is 1, not 0. So 2 is not a factor. This is going to help guide you. Basically, what we're doing when we're looking at these is we're going to do long division, and we're going to just look to see if the remainder is 0 or not. Let's go ahead and dive in. I see that this first one, it goes 4, 3, 2, 1, 0. It is in proper form, so I'm going to go ahead and rewrite that accurately. X to the fourth minus 3x to the third plus 6x squared minus 12x plus 8. I'm going to be dividing it by x minus 1. Okay. For this first thing, you have to essentially match it like we did over here on the right. You ask yourself, how many times does 3 go into 9? How many times does x go into x to the fourth? Well, x times what is going to be x to the fourth? This is what we're asking ourselves. There's no coefficients, so it's only going to be x to the third power. 3 plus 1 is equal to 4x's. This is what we want. So I'm going to put x to the third. And now I have to multiply it by x and negative 1. So I'm going to go ahead and do this. X to the third times x is x to the fourth. X to the third times negative 1. I'm multiplying it here. I have to distribute it to both. Is going to result in a negative 1x to the third. So I got that by multiplying x to the third by both x and negative 1. Now, for the long division, notice it is always subtraction. Always subtraction. So in order to represent this, I'm going to draw parentheses because like I distributed the x to the third, I do have to distribute this negative in. This is going to test your ability to process integers quickly, fastly, and accurately. So right now, what I'm going to be looking at is x to the fourth minus x to the fourth is 0. Now I'm going to look at negative 3x to the third. A negative times a negative 1x to the third is going to be positive. So really what I'm processing right now is negative 3x to the third plus 1x to the third. And this is going to result in negative 2x to the third. If you have to distribute it, do it on the right side. Don't do it in the long division box. Okay, now I'm going to go ahead and bring down my number. I'm going to bring down positive 6x squared, and I'm going to continue the party and just restart it. I'm going to ask myself, hey, x times what is going to be negative 2x to the third? Notice how I'm using the same x, but now I'm looking at this part. I'm looking at my new leading term. So I think, okay, how do I make x to be negative 2x to the third? Well, I know that x squared is going to be necessary, and I also think it's going to be negative 2. So I'm going to go ahead and distribute. Negative 2x squared times x is going to be to the third power, and I also have to multiply it by negative 1. And I remember I'm subtracting. Okay, this is where I'm going to distribute in my head. A negative negative is a positive. So really, 2x to the third and negative 2x to the third is going to make 0. This is going to make 4x squared. Now, I'm going to go ahead and bring down my next number, negative 12x. I'm going to repeat this process. I'm going to ask myself, x times what is going to be 4x squared? I am looking at my leading term. So, well, x times x is definitely going to be x squared, and I need a 4. So, I'm going to multiply 4x by both x and negative 1. Oops, I did forget to write this up top, and that's actually rather important. Plus 4x because it's a positive. So now 4x times x is going to be 4x squared. 4x times negative 1, negative 4x. With long division, I'm going to be subtracting, and I go ahead and subtract. A negative negative is going to make a positive 4x, so I'm going to have negative 8x's left over. Bring down the 8. I ask myself one final time, x times what is going to be my leading term? Always look at the leading terms. How do you get negative 8x? Well, there's already an x. What's the only part that's missing? Okay, it's the negative 8. Negative 8 times x is going to be negative 8x. Negative 8 times negative 1 is going to be positive 8. And I subtract 0. I brought all the numbers down, so I'm done. Now, what is my remainder? Well, the remainder is 0, meaning x minus 1 is a factor. Let's do one more example. You are going to need to practice this skill. So, again, same problem. Is it a factor? Now, I do want you to notice that it goes from 5, 4, 3, 2, 1. When you are dividing, since there is no just number, if you look up above, you know how we had a plus 8, I am going to add a plus 0. This is going to enable my division to be satisfactory. This is just something I need to do to be accurate. If I had something where it went like 3x to the 5th plus 9x to the 3rd, before I put it in the long division, I would have to include a 0x to the fourth plus 9x to the third. What I'm trying to illustrate right now is that polynomials go in descending order from exponents to finally a term without an exponent. Or you can think of it as x to the 0. But when you're doing division, you do have to include it. This is just for the future, planting the seeds for the harder problems. So really, I'm just going to go ahead and plug it in. 3x to the fifth plus 20x to the fourth plus 9x to the third minus 92x squared minus 60x, and then plus 0. I'm going to go ahead and try to divide it by 3x plus 2. So when you're doing this, look at your first term, 3x, and I'm going to have to multiply this whole thing by 3x plus 5. You ask yourself, hey, 3x times what is going to be 3x to the fifth? Well, both of them have a 3. X, there's one of them. How many more x's do you need? Well, I need 4 x's. So, 4 x's. I multiply it to both, and I'm going to get 3x to the fifth plus 2x to the fourth. And I remember it's long division. I'm going to go ahead and subtract. This turns into 0, and this turns into 18x to the fourth after I distribute the negative. This is what I want. That 0 is a good sign that you picked the right number. Now, as in long division, bring down the next number. I have to repeat myself. Again, I ask my same question. How do I make 3x? I'm going to multiply by something, and I want it to be equal to 8x to the fourth. Well, 3 times what is 18? X times what is x to the fourth? I hope you're able to see how I was able to generate a positive 6x to the third. All right, 6x to the third times 3x is going to be 18x to the fourth. 6x to the third times 2 is going to be 12x to the third. I have to remember I am doing long division, so I'm going to be subtracting. 18x minus 18x to the fourth is going to be 0. 9x to the third minus 12x to the third is going to be negative 3x to the third. And I bring my number down. Again, same type of question. You are asking 3x times what is going to be my new leading term, 3x to the third. How do you make 3 and 2 negative 3? Well, negative 1. X times what is going to be x to the third? X squared. So let me go ahead. This is what I'm going to be multiplying by. Negative 1x's second power times 3x is going to be negative 3x to the third minus 2x squared. And I'm subtracting because I'm doing long division. Notice how the negative and the negative makes the positive, forming the 0. And then it's going to be negative 90x squared. Bring down the next number, negative 60x. I'm going to ask myself 3x times what is going to be my new leading term? Well, 3 times what is 90? Well, 3 times negative 30 will produce a negative 90. X times x will be x squared. I'm going to now distribute the negative 30x to to both divisors. This is going to result in negative 90x squared minus 60x. I subtract because it's long division, and I get 0 plus 0. Now, it doesn't necessarily change things here, but I do want to note that this is not my remainder. Notice how the next term is going descending order. X to the fourth, x to the third, x squared, negative 30x. I'm looking at the quotient. This number that I'm going to be finding, I still have to bring the 0 down, and that's why it's so important that I added it. Well, this is necessarily not a killer question. 3x times what is going to be 0? It is the one and only 0. Plus 0. 3x times it is going to be 0 plus 0, which is going to be just 0 at the end. However, notice how it's important to get that. This 0 is very much a part of it. This final number right here, this 0 here, is my remainder. So it is 0. So the idea is that 3x plus 2 is indeed a factor because the remainder was 0. This is a key skill. Practice the long division until you're good at it. It's okay to make mistakes. This is it for now. Ciao.